In this video, we continue our look at infinite series. Specifically, we take a look at the limit comparison test. The limit comparison test is similar to the direct comparison test in that we are going to be comparing a series that we start with, a sub n, to a new series, b sub n. Just like the direct comparison test, our terms have to be greater than or equal to 0. In other words, the limit comparison test must be done on positive term series. However, unlike the direct comparison test, the order of these terms doesn't have to be shown. We do not have to show that a sub n is smaller than b sub n or a sub n is larger than b sub n. Instead, the limit comparison test focuses on the limit. We will be taking the limit as n goes to infinity of the quotient of the terms a sub n over b sub n. And depending on the result, it will determine our conclusion. Most often, we use this first case in the limit comparison test. That is, if we have a series a sub n and a series b sub n, and we take the limit as n goes to infinity of a sub n divided by b sub n, and we result in a limit that is a finite number not equal to 0, then either a sub n and b sub n will both converge or they will both diverge. So whatever b sub n does, a sub n also does. Let's take a look at an example to show you how the limit comparison test is put into use. Example 1. Use the limit comparison test to determine whether the following series converges or diverges. We have the infinite series n equals 1 to infinity of 2 over 3 plus the square root of n. Now, you might be looking at this series and saying, you know what, we could use the direct comparison test to do this problem. And in fact, you could. But we can also use the limit comparison test. Let me show you how that's done. We are going to start with our series a sub n, being the original series, n equals 1 to infinity of 2 over 3 plus the square root of n. We want to compare it to a new series, b sub n. What should we let b sub n be? Well, I'm going to choose 2 over the square root of n. What do we know about 2 over the square root of n? Well, if we pull out the constant multiple 2, I'm looking at a p-series. Specifically, I'm looking at a p-series where the power on n is 1/2. And since 1/2 is less than 1, we know that the p-series does what? It diverges. So our series b sub n, which we're going to compare to, is a p-series that diverges. So let's apply the limit comparison test. The limit comparison test says, let's consider the limit as n goes to infinity of a sub n, the nth term in our original series, divided by b sub n, the nth term in our new series that we're comparing to. And if I want to take this limit, well, first of all, I'm going to take this complex fraction and I'm going to rewrite it in a simpler form. In other words, when I divide, I'm actually going to flip and multiply by the reciprocal square root of n over 2. So in other words, I'm actually taking the limit as n goes to infinity of 2 times the square root of n over 2 times the square root of n plus 6. Now, as I take an infinite limit, remember, as n goes to infinity, these two terms here are going to have the most impact on that limit. So we can actually just focus our limit on those two terms. And so we are actually looking at the limit as n goes to infinity of 2 over the square root of n divided by 2 times the square root of n. And doing a little quick cancellation, right? What does that tell me? I'm actually looking at the limit as n goes to infinity of 1, which is just 1. Well, what do I know about that? Well, the limit comparison test said that if I took the quotient a sub n over b sub n and took the limit as n goes to infinity of those nth terms, and I resulted in something that was a finite limit L not equal to 0, then whatever b sub n did, a sub n also had to do. And since b sub n is diverging, that means a sub n is diverging. Let's write that down. So if we let our b sub n series to which we are comparing be the series 2 over the square root of n. And just as a side note, we could also use 1 over the square root of n. You didn't have to include that too, but I just happened to do so. So let's let b sub n be 2 over the square root of n. This series diverges by the p-series test. Since the limit as n goes to infinity of 2 over 3 plus the square root of n divided by 2 over the square root of n equals 1, which is a finite limit not equal to 0, the limit comparison test tells us that our original series, 2 over 3 plus the square root of n, just like the series b sub n that we're comparing to, will also diverge. Whatever happens to the first series also happens to the second series in the limit comparison test.